All right, here's your next example. We've got negative cosecant of 3 pi x minus pi halves. So again, we want to factor out the things away from the x, this 3 pi. So we're going to have negative cosecant. We factor out the 3 pi, and you're left with an x minus 1/6. So that means that your amplitude is the absolute value of the first number, which is 1. Your period for cosecant is 2 pi divided by the number of cycles, which in this case is 3 pi. So that means your period is going to be 2/3. The midline on this case is 0. And your phase shift is going to be to the right 1/6. So let's put this information on the graph. We have a midline of 0. We have an amplitude of 1. We also have a period of 2/3 and a starting point of 1/6. So I need to make my graph, I need to label my x-coordinate with some things to give me the 1/6 and the 2/3. So I'm just going to go ahead and label this first line as 1/3, which makes this second line 2/3. So now that I've done that, that means I'm going to move to the right 1/6. 1/6 would be here. And then I have a period of 2/3. So that would be 1/3, 2/3. So it would be right in the middle of this one. So that means this one was 3/3 or 1, right? So if I took 1/6, which is half of a third, and I added 2/3, that would be 4/6 plus a sixth, so that's 5/6. So I had a starting point of 1/6. I had an ending point of 5/6. Now I need to draw the cosecant function, the negative cosecant function. Recall that cosecant is like sine that has been moved out. So I have the negative sine function, which looks like this, right? So now if I take this piece and I put my asymptote right here at 0, this one would flip out this way, and this part would flip out to the top. So these outside pieces are cosecant, the inside piece is sine. So I'm going to lightly put in my negative sine function, which would look like this, right? I'm going to put in my asymptotes. So that would be this one right here. So there's my asymptote, which means now that I can draw in my cosecant function. Which looks like this. Here's your next example. We've got tangent of 2x plus pi fourths, and then adding 1 to that. So again, we want to factor out this 2 away from the x. So that's going to have a tangent of 2 multiplied to the x plus pi over 8 and plus 1. So remember that tangent doesn't have an amplitude, it goes on forever. We have a period. Remember, tangent's normal period is pi. So we're going to take pi and divide it by the number of cycles. We have a midline of 1. And we have a phase shift of negative pi over 8. So that means I got to move my line over here to the left a little bit. And now I'm going to label these. And so I think I'm going to use this first line as 1/4 of pi. And then that would be this is 2/4 of pi. So that means my function is going to have a period of pi halves. In other words, it's going to go across 2 lines, right? And it's going to be moved to the left of 1/8 of the line. Or in other words, it's moved to the left pi 8, which is half of this line about right in here. So let's put those lines on the graph. We have a midline of y equals 1. We have a phase shift to the left, pi 8. And we have a period of pi halves. In other words, it's 1/8, it's pi 8 left from pi halves, right? Now from here, we are going to graph our tangent line, but let's first label where we started and where we ended. So we started over here at negative pi 8. So if we take negative pi 8 and we add in pi halves, so that'd be 4 pi 8 minus 1, so that's 3 pi 8 is where we ended right here. Now we're going to draw in our tangent function. Remember, the tangent function has an asymptote right in the middle. And our first part of our line, it goes from the midline, it goes and curves up. And from the end part of the midline, it curves down. So there's the graph of our tangent function.